Roy. I don't know if he's in the meet. He said that he take a break with take a coffee.
Okay. Okay, nice. Okay, so hello everyone. So do you hear me well? Yeah? Everybody is hear me? Yeah? Okay. So as you see, I will be the MC for this event. First of all, thank you all for watching this first TypeScript online event. So I got some slides to introduce you this meetup. This is our 25th meetup since TypeScript creation, and we organize meetup every 2 months on the first Tuesday, apart from this strange COVID period. We make various events, regular events, special event where we focus on some topic, apéro. Don't know if this means anything in English, but this is where we drink and talk about TypeScript, and online events like right now. If you want to support us, we are an open collective, so this money allows us to pay Meetup, domain name for website, record event, etc., etc. If you want to discuss about TypeScript and stay in touch with TypeScript community, we have a Slack that you can join. We have also a GitHub repository. I will talk about it later. We also have a YouTube channel where you can see past recorded events. As you can see, all the TypeScript team is on Twitter. The Meetup also have an account where we published information about the next event. So if you don't want to miss news about the next event, you can follow the TypeScript Tutors account. Now get back to the GitHub repository where you can submit talk on the issue tab. So we always search for speaker, so don't be shy. We can help you. We search every level. This can be beginner friendly, no problem with that. We search on every topic, so language, feature, OSS, open source project, framework, etc. Of course, it has to be related to TypeScript, but that's all. Thank you very much to our lead bro, so Paridino Meetup, that helped us to set up this online event. Thank you, Paridino. And now things get real. Let's talk about the program. First talk is Implementing Complex Design Systems by Andrey Soloviev from Aircall. And then we have Combining Type System with TS and GraphQL by Rory Derk. So very great program. Thank you to both speakers. We are very happy to have you. You can follow them on Twitter. And last thing but not least, if you have some question, as we already say in the chat, use hashtag question on YouTube's live chat, and we will ask this question to the speaker at the end of the talk. So now it's time to begin. Thanks for your attention, and now let's get started.
Can you guys hear me? Okay, all right. So, hello everyone. My name is Andrey. I work over at Aircall, and today we're going to be talking about implementing complex design systems. We're going to be starting off with a topic that's a bit less code and more design, as you can see by the name. The talk goes as follows. So at first, we're going to talk about, well, what is a design system? Then we're going to see why do we need a systematic approach to building applications. And then we're going to follow up with some tips on how do you go about implementing one. We're going to actually afterwards take a look at some examples from Aircall and some things that we've learned on our way. So at first, let's see, all right, why do we need a design system? And basically, I like to approach this question from a personal standpoint, from projects that I had worked on in my professional life, and issues I have faced as a developer. And one of the major issues that I have faced with when working with design teams is that, well, basically there's no communication whatsoever between design teams and developer teams. You know, design teams like to work in their own corner. They usually have their own studio or their own desks. They're kind of far away from you. So every time you need to talk to them, you need to go there, you need to find an available designer, you need to find someone who actually wants to talk to you. And it makes building real world applications actually pretty hard. Secondly, is that there was no documentation to speak of. You know, you arrive on a project, you start checking out the components library, and how does something work? How does this thing work with another thing? How do these two link up together? What's happening here? What does this do? What does some other component do? You just don't understand. Speaking of components, you know, the usual component hell that you're faced when you join a new project. Maybe some of you have already seen this, basically, right? This is your the usual storybook components from a project. This is actually from our old phone system over Aircall. We just have our atoms, some components. Okay, we have components next to atoms. We have some badge filters. Who knows what they do? Some inbox counter modals. Then above that, we have more components in atoms, and it's just, you don't understand what's happening here. You really don't. And so surely, right, we can climb out of this hellhole, right? And the answer is, as you might imagine, is yes, use systems. All right, that's the end of the talk. Thank you, everyone. No, okay, this is not the end of the talk, of course. But since we started talking about design systems, let's see, what is a design system, right? And well, a design system is basically a solution to designing things in a disorderly fashion, right? It's bringing, you know, some order into chaos. It's making systems. And as developers, you know, when this was introduced, this might have been as something new in the world of design. But as developers, we have experience with building things, right? We systematically, right? We have IDs, we have classes, we have our reusable functions. Well, actually, using and building complex systems is part of our profession, right? But code is not design. these two things are not the same. And so a design system aims to bridge the gap and bring the two worlds closer. I like this quote from Andrew Caldwell. He was a design system lead over at WeWork and designer at Adobe. He said that the design system is the end result of a systematic approach to design. It's the harmonious package of design, code, guidelines, and documentation that's used to build consistent, on-brand, and efficient websites and products. In short, it's not reinventing the wheel every single time. So now that I hope I got your attention, right? Let's get to it, right? A design system brings a lot of things to the table. Number one is, of course, efficiency, right? You have faster iteration, faster features, happier developers, and well, happier customers. Because let's not forget about the people who use your product and pay your salary in a way. Number two, user experience and user interface, because you would want a homogeneous UI and UX across your entire application suite. Number three is cleaning house. As we said, let's bring some order to chaos. Let's make it so things at least start to make sense in terms of organization and usage, and it's not just a bunch of components sitting in a folder. One source of truth. We love that word, right? It's and in the design world, it also has its meaning, right? And in our world as well, it's not the 3 separate sketch files you got lying in your Dropbox. It's not the one designer who used to work here a year ago but doesn't anymore. It's one source. It's your design system, the one you have in front of you. Lingo is extremely important because we're talking about language, right? Language is something that we all use on an everyday basis. And when everyone speaks the same language, when everyone uses the same naming conventions, the same grammar, then we can all be on the same page. Number 6, brand. Because let's not forget that you're not making software in the void. You're probably working for a company, and the product you're working on represents a brand. Your design system has to follow that thinking and implement the brand design guideline. So let's do it. Right, let's go for it. Let's get into the thick of it. All right. First, how do you go about making a design system? Well, collaboration. I know this might seem like something, hey, dude, collaboration. Come on, we all collaborate on a daily basis, don't we? Well, yeah, but still, I think that this is worth to be reminded. Actually work with your designers. Go, put your workstation next to a designer, talk it out, get into it, be interested. As a developer, you have experience building systems. Your input and positive feedback can only be valuable because the design system is supposed to be a unifier and not a divider. It's supposed to bring the two sides closer and help them work together towards a common goal. And since you're using design systems now, and you're the cool guy on the block or the cool gal on the block, you need to evangelize. What does that mean? Well, simply, you need to sell it, right? You need to sell it to stakeholders. You need to sell it to your teammates. You need to sell it to people who are probably going to be using your design system in other projects across the company. You need to sell it to product. You need to sell it to all those people you're going to be working with on a daily basis. Now, let's not forget that we're making a design system, and of course, the role of design, which could have come first, right? But it's primary, it's pretty big because design establishes the foundations of your design system. In my experience, building a design system should actually come from the designers, right? Because they establish the tone, the voice, the copywriting. They establish the lingo you're going to be using. So the role of design, it's a two-way street, right? Both of you are in this. So, but we are actually, after all, in a TypeScript conference, and we're building. Some of us are probably building interfaces here and using components on a daily basis. So let's look a little bit into that. What kind of structure could we follow with components? And I guess some of you might have heard about the atomic structure, right? The atomic structure is something that splits your components into atoms, into molecules, organisms, and then uses those to build pages and templates out of them. We're going to probably skip the templates part because we're not really using them, but we're definitely going to take a look at the atoms, the molecules, and the organ. So let's start with the atoms, right? What is an atom? Atom is the simplest, most basic component you can have in your design system. It's the building block, right? The little Lego brick, the little yellow Lego brick that you use to build everything else. An atom is an avatar. It's a flag. It's your logo. It has no other function other than doing the very simple thing it's supposed to be doing. Molecules. Molecules are usually components composed of atoms. If you have two atoms in, say, wrapped in a div, then you probably have a molecule, right? So it could be a button. This is a button. Inside it, you have the atom for text that you're going to be using. This is another button with a checkbox. It's the button, and inside you have an atom for an icon. This is your input. It's an input. On the right, you have the button for a cross, an icon. This is this is an item. You have a switch on the right. You have text on the left. This is a tab bar, right? These are all real components I'm showing you from the Aircall design system, by the way. The one we use on a daily basis to build the phone, to build our applications, right? You have your tab bar, your to-do, you put the icons and the text. On the right, you have the avatar that we just showed, that we just saw in the atoms. Organisms. Well, organisms, again, in my opinion, in my experience, well, they're a bit complicated because they're very specific to the application that you're building. Organisms usually contain a lot of logic. They contain a lot of molecules, atoms, a lot of interoperating moving parts that shift constantly. And so for me, organisms are not really part of your design system. They're part of your app. They're built using your design system, but they're not in your design system per se. I wanted to touch real quick on the store, right? Because some of you might be working with stores such as Redux or such as MobX, simple implementation. For me, that's a no-go. Your design system components should not be tied to your store. They should not be aware of the data structure of your application. That should be completely separate. If you have an avatar atom, it should have like a string, a URL prop. That's it. But it should not really know what's happening with your store. Pages. Again, real quick, these are not, again, in experience, these are not part of your design system. Pages are part of your application. And pages should be dumb, stateless components inside which are going to live your organisms, are going to live your components, which are enhanced by your store, your containers, and your wrappers. And last but not least, I'd like to touch a little bit on sync with mobile, because some of you might be working on products that also have iOS applications and Android applications. And of course, you got to sync up with the developers working on those in order to understand how they're using the design system, how they're implementing these atoms and these molecules and these concepts that you're trying to implement inside your web application. And one of the things we started doing at Aircall with our iOS and Android developers was a spreadsheet. It's it's not doesn't sound as impressive as it could, but this is a screen from our actual spreadsheet over at Aircall. And as you can see on the left, we have the components that we're using. We have the image with the category, if it's a molecule, if it's a button. And then on the right, somewhere toward the center, you have the device and the button, Android, iOS, desktop, and especially the naming of that component. Because we talked a lot about lingo, about using the same language. And so this is where we tried to kind of unify the language we're using to describe our components. so button, squircle button, for example. And where we tried, and then the developers responsible in every one of those platforms are going to go inside and try to modify the naming if necessary to kind of follow the same guidelines as everyone else. We have a description of use. We have a status on versioning. If it's something that we just started, 0, it's not implemented. So here we go, 0, the component is not implemented yet. 1, the component exists, but it's not up to date. And 2, the component exists and it is up to date. And then we did a little percentage on where we at on Android, iOS, and web. And this serves as a good starting point for talking where are we going to go from here. So let's take a look at Aircall, because we have a big application, a client-facing application, which is our phone. Basically, it's a phone system, whose design was started in Sketch and Zeppelin. Pretty classic setup, at least for the time that when the design system was done. Sketch files is where the designers worked in, and Zeppelin is used for developer handoff. It's where you go and you inspect your designs. All of that was then migrated into Figma, because Figma is now the go-to tool for a lot of designers, which it's basically like Sketch and Zeppelin in one, if I could say it like that. And I would like to show you some snapshots from our actual Figma files, and this is how our designers like to organize things in colors, with every single color that we use in the app, for the typography, the titles, the subtitles, paragraphs, etc. For the input fields, the default focus, etc. And then we take that, and at least for now, we put it into a storybook, as you might have guessed. And a storybook, this is how our actual storybook for now looks. You might remember that big waterfall of components that I showed you previously. Well, as you can see, it has been replaced by neat folders organized in atoms, molecules, organisms, and pages. And generally, each single component is now also neatly organized into a separate folder with its own variants. And I would like to actually that we take a look at one of those. It's a call card. And as you can see, we organize the call card by the variants on the left: default, without contact name, anonymous, checkbox and hidden actions, checked and hidden actions, and basically any variant that we can have. Those of you who've used Storybook before might be thinking, well, why aren't you using knobs to do that? Storybook knobs are, are small switches and toggles that allow you to toggle the state of a component. So say if you want to change the text that's in there, you're going to have a small input where you're going to change the text inside. But instead of doing that, we found that knobs tend to get very chaotic. You end up on a page with a component and you see the knobs on the right, and they're going to be like 20 knobs, and they're all supposed to do something and change the state of a component in some way. So instead of doing that, we decided to organize them on the left with a very precise application inside the app itself. So it switched. Thank you very much, Keynote. Sorry for that. Apparently doesn't want me to play the video. Can you do that? There you go. And now it doesn't want to scroll. Well, I guess these things happen, but I think you got the gist of it. So we have our components on the left organized in actual precise applications, the way they're actually used inside our app. Well, let's move on, and let's move on to actually measuring the efficiency of the design system, right? Because you have worked on this for so long and very hard, right? You've gone away, you've evangelized, you have spoken to everyone about it, you have implemented a very nice design system, a very clean storybook. It's great, but you did all that work, and now you kind of have to just, what was the point of it, right? And so we had 3 goals at Aircall when we measured the efficiency of our design system: ease of mind and designer-developer satisfaction, a homogeneous user interface, code and design reusability. And today I would like to focus on code and design reusability. E.g., how much CSS code did we write since the introduction of the design system? There's a Medium article actually on this by Cristiano Rastelli that inspired us to actually do that. And so we measured it like that. So this little chart, it's a little blurry, I'm sorry, but the screenshot, I couldn't get it to actually be in a better resolution, and we're a bit bigger. But I think it's what we're trying to show is a bit visible, so it can be seen nonetheless. So in green we have the insertions, in red we have the deletions, and in gray we have file changes, right? And as you can see in the beginning, so our design system was started in November of 2019. So this is like, I'm going to show you a snapshot of a year. So in the beginning, over at 0, first in November, we have the start of our design system. We have a lot of insertions, a lot of deletions. So this is where we started working a lot on it. We have a lot of file changes, a lot of activity, actually. You see a little gap, but somewhere in end of December, beginning of January, but that's because Christmas holidays kicked in. And so there's a lot of activity, a lot of stuff happening, you know. And I'm sorry, I said that was the beginning of the design system. I'm wrong. There was no design system yet in the code then. There was no design system code yet in the code. A lot of insertion, a lot of deletions, a lot of file changes. And the design system began to be introduced on the right, if we move to the right, somewhere around February. That's where we started working on the design system. That's where we started organizing all of our components into molecules, atoms. And the cool thing that happened is this. This is what happened next. After the introduction of the design system, our number of insertions, of deletions, file changes fell drastically. And this is what I'm showing you is not stale activity. We're still working on the project back then very, very thoroughly. We're still pushing features, fixing bugs. There's a lot of stuff actually happening. But as you can see, we're not making a lot of changes to the components themselves, to the atoms and the molecules of the design system. We're just using them. And if we go even further, we can still see the same trajectory, same virtually no insertions, virtually no deletions. We see a big spike over somewhere at the end of October. That was a big rewrite of a view, of an old view, into, again, a view that's more composable. So that's what the big spike is over there. But as you can see, this relative calm, right? This is something that I love about using a design system, and that it brings a lot of stability to the table. And you focus on the functionality of your app and not on making changes to your components. So by now you might be wondering, okay, I like this stuff. This is cool. Design systems, nice. But is this for me? Well, I could say that judging from what we went through, if you're a small team, right, you have a small project, there's like 2 developers on the team, then you know, the answer will probably be no, right? Because it would actually hinder your process, you know, making, you know, a design system from scratch, very organized. It would actually hinder your process more than it would help you. It would distract you a lot, and you would actually need to manage it. You'll need to manage your design system plus manage your application, the one you're trying to build as a small team, pushing features every single day. It's actually pretty hard if you're trying to build at the same time a custom design system in-house. But if you're part of a growing team, you know, you're growing in size, there's not just 2 or 3 of you anymore. Now you're 10, 20, 30. And you need to actually, as we said again, you know, to put some order into chaos, then the answer is yes. This is going to help you organize your thoughts. It's going to help you organize your development process. It's going to help you just not think about the design system and about the components themselves. You just pick something from a shelf, you use it, you focus on the functionality. rinse and repeat, rinse and repeat. So what's next for us at Aircall, right? Because what I show you is still not complete. You know, a design system is something that it's like your product. You know, it follows your product. It's maintained. It should be maintained all the time. It's never finished, right? Our next steps are extensive documentation. That storybook that I showed you is still yet just a storybook, and it needs to be documented. And this is where storybook docs, for example, would, I think, play neatly, would be a nice addition to the process. We could actually document each and every single component in each and every single variant in the way that our designers intend them to be used and to be documented. Continued maintenance. As I said, you know, design system, it's never finished. It should be supposed to be maintained. Because you got, you know, your stale code starting to, you know, come in and stinking. So you need to actually, you know, devote some time to that as well. And of course, focus on quality over quantity. As a bigger development team, now we can actually afford to do that and actually at least try and do that. We can focus on the quality of what we ship. The quality of the design system, quality of user experience, quality of user interface, animations, you know, that's the kind of stuff that as a developer in the years that I've been working in the industry, I've rarely had the opportunity to actually devote my time to it. And maybe we'll actually get to that and actually do it. So that's it for me, guys. I hope you enjoyed the talk. Thank you very much. I apologize for the small technical hiccups I might have had while presenting this. Thank you. As the guy said, I'm at Mindrave on Twitter. And yeah, everyone, thank you very much.
We can ask the questions, I think. If you're okay, Andrey?
Yes, of course.
Yeah, there is one question.
I just realized my camera was off all this time. Okay.
From Kevin. So yeah, so do you use React to build your component from a design system at Aircall?
Yeah, we do. The products at Aircall, the phone is built using React. So it is the design system on React. Yeah, totally.
Okay. Thank you. And there is another part of the question. So have you heard about web components?
Yeah, of course. I've heard about web components. I know that people at Stripe, I think, are very big on web components, and their usage, they're pretty cool. But at the time, we're not using them at Aircall at all. We're not using them to build our products. Well, maybe we should look into it.
Okay, thanks. Another question. So how are the styles of the components customizable?
Oh yeah, that's a good one. Styles. So the styling of the components for now is done using Sass. We are aiming for as less customization as possible, actually, because we're building an in-house design system, and so you know, our designers are figuring out ways to actually, you know, that we use the components, that we compose them all together without having to style them every single time. You know, so each component has its own style sheet, and some of the components, the few components that do require some overrides, they have a class name prop that we use to override, you know, add a class on top of the component class that's already there. But we aim for minimal overrides as much as we can, at least to the degree if possible. I hope that answers your question.
Thank you. And we got another question. So what's the difference between design system and Premang library?
You know, I will not lie to you. I have not heard of the Premang library But now that you say it, I will definitely take a note of it and look into it. But I
Okay.
have not heard of it. I cannot answer that question. I'm sorry.
I don't know too, programming library. I'm gonna watch that. Okay, so another question: what are the first benefits you got with the developers when you started your design system?
Okay, so the major benefits that we got were we actually started seeing them when we finished migrating the design system, because I show you that waterfall of components that we had, and then the atoms and components, because we migrated from that wall of components into an atomic and molecular structure. And so that took some time, as you can imagine. That took about 2 to 3 months, I think, to migrate everything. And when we finished that, when we migrated them, that's when we started to actually seeing the benefits of peace of mind, in a way, having just components that we can use to build a page without having to rewrite them every single time. A lot of times in my old experiences that I've had, when you entered a new project and you needed a component that didn't do something, that had some new functionality, you just built a new component. You didn't pick up something that was already there. And you don't have to do that here. You just pick something from a shelf and you use it, and you use it, and you feel that. And as developers, we felt that we were moving faster. That chart that I showed you, with the inserts and the deletions, how it went down, right? That's what you see, actually. That's that's ease of mind, that relative calm that comes with using a design system, is that you're not really focusing on developing and changing components each and every single time. That takes a lot of time, a lot of work, and you're focusing on the functionality of your application much, much more.
Thank you for your answer. We got other questions. So, do you use design tokens, and how do you manage them?
Got me there. No, we don't. We did not use design tokens. Not yet is my answer. Maybe that should have been a part of my slides. The design system at Aircall is evolving, and we are starting to look into design tokens and how we could use them in our design system. Yeah, I hope I can update this talk in a few months with some some good stuff like design tokens and maybe style components, etc., etc. We're looking into that.
All right, so thanks again. Next question. At what point scale do you feel using Storybook becomes a must-have for a company? And where would you host your design system? Locally or an NPM registry? Or something like that?
Mm-hmm. So it depends on the way you use Storybook, I guess. If Storybook is generally useful to aid in development, right? It's useful to develop a component outside of the constraints of your application. It's very useful for visual development because you see the changes you make in the window in front of you, right? So Storybook is generally useful, even if you have just 1 or 2 or 3 components that are not a design system component. But if you just have components that you want to see visually outside of your app, you want to develop visually, Storybook is extremely useful. Now, Storybook Docs, on the other hand, which is documentation. Well, that depends. If you have a design system, if you have components that you feel that need to be documented, say for example, you have a bunch of junior developers that just joined your team and they don't understand how your components are supposed to work. So you spend time explaining that, right? And some documentation would help with that. So boom, you add Storybook Docs and you start actually adding documentation to your design system. So yeah, it depends on how you're going to use a Storybook, I think. It depends on your goals as a team, as a company, as a tech team. Yeah, but generally, it's a very useful thing to have from the start. And then as your project evolves, as your components evolve, so does Storybook. It evolves as well.
Okay, thanks. Last questions. So do you start from scratch building your design system or fork an existing one?
Yes, we started from scratch. We did not fork an existing design system. We had a designer who was actually working more or less full-time on the design system. And so she developed Leia. She developed that thing, all of it, all of the components, all of the atoms, the molecules, the organisms, all of that from scratch.
Okay, thank you very much, Andrey. I think there is no more last questions here. Yeah. Okay. One more question. Do you develop a language so dev can easily search a component for like show a price that increased or decreased?
Develop a language. I'm not sure I understand the question exactly. I'll try and maybe guess. Unless Tristan, you have some, you can be a bit more precise. But no, not really. We don't develop any like specific language. As I said, what we try to work on is naming conventions across our entire design system, so that if someone says call card, that we know what that person is talking about, right? If someone says avatar, we know what that person is talking about. We know the component that's talking about, and we can just search that in Storybook or in our code base. We can find it, and then we can easily find it and take a look at it. That's as far as we've gone, and well, it's a pretty useful exercise to do anyway. I hope I answered your question more or less.
Yes, okay. So, oh, no, that's okay. Okay. So thank you, Andrey. Thank you for answering the question, and thank you for your talk. And now,
thank you guys. Thank you very much.
This is time now for Roy, I think. So, bye, Andrey. And now, Roy, the screen is for you.
Great. Hi, so good evening, everyone. I'm tuning in from Amsterdam, the Netherlands. So I hope everything's safe at your side as well. So let's get started. So today I want to talk to you about how you can use TypeScript together with GraphQL. And there are some interesting points that both technologies can use from each other. So that's something I'm going to elaborate on. And also I'm going to show some demos to see how this actually works together. So who's this for? So I guess you're all TypeScript developers, or maybe you're a TypeScript enthusiast. Maybe you still need to get started with TypeScript. This talk is best suited for everyone that already knows how to use TypeScript and maybe already knows GraphQL, but it's not. You're not supposed to know something about GraphQL for this talk. So I'm going to tell you more about what GraphQL is if you're interested in learning more about it. A little bit about myself. So like I told you, I'm Roy. I'm from Amsterdam. Here in Amsterdam, I also work for the city of Amsterdam, where I'm working on open source projects. We're working on numerous APIs and front-end applications that are used by people that work for the city, but also people that visit the city. And in general, we try to make the life of everyone that works and lives and comes to Amsterdam a little bit better by making applications by the city for the city. And I also teach React and GraphQL. And I sometimes work with other companies as well to...
Sorry, Roy, have you shared your screen?
Oh, no, I'm still needing to share my screen.
Oh, okay. I think this was an introduction.
Still an introduction. So here are the images that go with the introduction. So like I told you, I'm Roy, so I work for the city of Amsterdam sometimes on open source projects. And you can also find me on social media with the name @GetHackTeam at Twitter. So what do you already know about TypeScript? So like I told you, I'm going to assume you know quite a lot about TypeScript already. You know about TypeScript, how it works with types, how you can create a TypeScript server maybe, or how TypeScript works with Node.js. So I'm going to assume that's all knowledge you have. If you don't, TypeScript documentation is really good. And something else you know about TypeScript, it has types, right? Types are basically the most important thing about TypeScript, because otherwise you would just be using plain JavaScript. So next to TypeScript, GraphQL will also have types. So this is very important to know, and it's also the foundation of this entire talk. So both technologies, they have types, and those types can be joined, they can be combined, and they can be used together to even strengthen your entire application. So, like I told you before, you don't have to be familiar with GraphQL already, but if you are, that works. If you're not, I'm going to give you a small introduction of what it is and how you can use it. So, basically, GraphQL is a query language for APIs. So, GraphQL is not something entirely opposed to REST APIs. It's just,
You share your slide?
yes, am I not sharing my slide? Oh, somehow Google doesn't like me today. So if you're not familiar with GraphQL, that's better, right? Right. So if you aren't familiar with GraphQL yet, I'm going to show you some pointers about what it is and how you can use it. So GraphQL is a query language for APIs, like I just told you. So it can be used opposed to REST. Like REST, it's also a convention. GraphQL is also a convention. So with GraphQL, you can know what type of application to expect and how the responses will look like, how you can query or mutate or even subscribe to live events. And this looks something like this. So you would have a query. In a query, you can define the fields that you want to receive. You can define arguments. As you can see, I'm asking for something called product. I'm going to send in some arguments, which is ID, which has a value of 3. And then I'm going to ask for some fields. And you can see in my response that it will have this format. So it's all JSON. Usually it starts with data, and then you get the information you're asking for. Now I'm asking for a single product. A product can also be an array. It can be basically anything how you've defined it in your resolvers and your schema, which we see later on. So basically the idea of GraphQL is you just going to ask for data, and you're going to get the exact same data that you ask for in the exact same format that you ask for. And this is all being done by a single endpoint. So no matter how many resources you're requesting, you would just have one single endpoint. So one endpoint is going to give you all the data that you need. So whether you're requesting something like products, or you're requesting information about users, or it doesn't really matter. It's all a single endpoint, and what defines what data you're being returned is your query or subscription or mutation that you're providing in there. So basically, you can send all this information from one single endpoint, and you get multiple resources. So we still have the product, which we requested before with the ID of 3. We have some fields, and then you can see we also have relational fields. So you can see we have categories and reviews. Those are what we call the relational fields in this case. So for both relations, we were going to request some data as well. So we have the title and the average reviews, and then you can see in your response that's being returned in this way. So we're going to get back all the fields for the product. And we also have relationships with categories, which is an array. And we also have relationship with reviews, which is a plain object. And those can be nested, and they can also be nested on a lot of different levels. But that's something else we go in later on. So I don't know if you've been using the GitHub API sometimes. They actually limited the amount of requests you can send with the GitHub API when you use it with GraphQL than defined with REST. So with REST, you can send way more requests than you can do with GraphQL. It's because of all the nested relationships you can get. So with REST, you would typically send a new request if you want to have category information because it's a relationship. And with GraphQL, you can send all those requests at once. And you can even send nested relationships for categories inside categories, and maybe even request products for those categories. So you can go real deep. So these are all the things you need to define in your resolvers, which we see later on. And also, like the most important part, it's based on the type system, just as we know from TypeScript. Basically, you can see it's something like this. So on the left, you can see I'm sending a mutation. So we already saw queries, which is operation type. And we also have an operation type called mutation. And like the name already tells you, mutation is to actually mutate data. Maybe insert data or delete data. It's for all sort of data mutations. And you can see we have a mutation called @offer, and we're going to input some data. And on the left top, you can see the actual mutation. And on the left bottom, you can see the input of this mutation. So we're sending information like a product ID, like a reseller, and a price. And then on the right side, you can see the actual response of the server. So it's going to give us an error because, as you can see, we're sending product ID with the wrong value. So it actually expected to receive an integer for product ID, and not a string. So you can see we have the same sort of type system with GraphQL. So it's going to respond to us that it won't be a valid output because you're sending an input with the wrong data type. And those type systems aren't too different. So we can already saw a little bit about the GraphQL type system. Now we're going to look more into detail to the type system. And as you can see here, both type systems side by side. We've created a type product, both in TypeScript and in GraphQL. And in TypeScript, we can also call it interface. We're not going to reuse this type, so we just leave it at type now. So we have two types, and you can see we have an ID, which is an integer, and we have a title, which is string. And as you can see, it looks very familiar. So we're going to use packages later on to help you translate those data types to each other. But the one thing you can already see, they both have basic scalar types. So in GraphQL, we call them scalar types. In TypeScript, you can see we've also defined those basic types. And the basic types in GraphQL basically are integers, strings, floats. They can be relational. We also have an ID scalar type, which really defines if something is an ID or not. And something that's a little bit different is you can both rely them to other types, by the way. That's also similarity between TypeScript and GraphQL. But something that's different is the required optional flag. So actually in TypeScript, you're going to assume everything is required unless you specify it. And in GraphQL, you need to specify if something is actually required. So it's it's the other way around. But it really defines your thinking. So when you're creating TypeScript interfaces or types, really think about whether or not something is optional. And in GraphQL, it's actually the other way around. You have to think whether or not something should be required. So if you automatically create those types from TypeScript, or maybe create TypeScript types in GraphQL, then this is something you might not think about that much, but something to keep in mind. So how can we actually combine TypeScript in GraphQL? So it should be really straightforward to build something yourself, right? Because there are just some overlapping scalar types and you need to define other things, but luckily there are packages to help you with this already. So there are actually two ways to approach this. So you can go for a backend with TypeScript and GraphQL. We can go for just a front end with TypeScript and GraphQL. Or maybe we can get the entire stack with TypeScript and GraphQL. And that's something we can actually achieve by using these two packages. So one is Type GraphQL and the other is GraphQL Code Generator. And actually, the GraphQL Code Generator can do some stuff that Type GraphQL can also do. But let's talk about Type GraphQL first. So Type GraphQL is a way to use TypeScript specifications and TypeScript types to create a GraphQL server. So your TypeScript types would be at the very basis of this server. So based on those TypeScript types, resolvers will be created, a schema will be created, and it can all be used together to expose a GraphQL endpoint. So I haven't actually found the time to create this entire demo for both the stack because we can talk about this all evening probably. So I'm going to show you how to use GraphQL Code Generator later on. Just a small intro on Type GraphQL with the usage of their website. So as you can see, it's more of a framework for creating GraphQL APIs with Node.js. And basically at the core is how you define your schema using TypeScript. So that's something that's being done right here. As you can see, you've just defined class. You can define all the fields, whether or not they're required. And this will be translated to a GraphQL schema. And that way you don't have to write your GraphQL schema yourself, because that's something that can be frustrating because it's going to lead to problems. So think about how you've defined the schema, and then you define TypeScript types, and then maybe you change your title, maybe it's no longer required, maybe it goes from maybe it goes for a string to an integer or a number, you never know. So at the very core of Type GraphQL is how you can use TypeScript definitions to create a GraphQL schema. And then it's all just boilerplate to create things like resolvers. As you can see, they're all typed because everywhere you're using the same types that you've created in the interface. So this is a really good approach to actually create a TypeScript GraphQL server from scratch. That's something I could show you, but something I'd rather show to you is how you can use GraphQL Code Generator to create TypeScript types from an existing GraphQL schema. So maybe you're using GraphQL and maybe you already have a GraphQL server, but it's built in something else. Maybe it's built in Python, maybe it's built in just plain JavaScript. Maybe you're using some service to create your GraphQL schema, something like Azure, maybe AWS. So let's talk about the GraphQL code generator and how it can help you create TypeScript types from a schema. So basically, GraphQL code generator is a CLI. So with the CLI, you're going to input some configuration, and using that configuration, it will create TypeScript types from a GraphQL schema. So this is basically what it does. But it can do a lot more, but we'll see later on. So the GraphQL schema is at its core now. So other than by using something like type GraphQL to create a GraphQL server, using TypeScript and create a schema from your TypeScript definitions, the GraphQL schema is now at its core. So whenever you change something to the GraphQL schema, your generated TypeScript types will change, and they should change because your schema has changed. So if you're requesting data from a GraphQL server and you don't have correct information about the schema, then it's all going to break. So you can remember how those types looked alike, right? So using this schema on the left, we're going to transform it to TypeScript types, as you can see on the right. And you can already see the similarities. Like I told you, it probably isn't that hard to create code that does this for you. But it's really nice to have a package do it for you automatically, because it can get really frustrating, and maybe there will be more types added later on. So basically what it does, it'll look at the similarities. So it's going to look at the exported scholars, and it's going to translate those to TypeScript types. As you can see, the ID scholar type in GraphQL, it's always a string. A string is, of course, a string. A Boolean is Boolean, integer, and floats are both numbers. So using this this simple scholar type is going to translate everything to TypeScript types. And by using Go, it will also help you using relationships with other types, because in TypeScript, we can use relationships with other types as well. So how does this actually work? So basically, you only have to install GraphQL code generator, and basically you have to install the CLI, which you can then run based on the configuration that you put in there. So you can use a wizard to set this all up, or define your own settings. So if you define your own settings, you're going to have some customizations that can be done using just a YAML file. So in your YAML file, you would import the URL to your GraphQL server. Then you can generate maybe TypeScript types or even components, which I'll show you. So let's look at the demo code that I created for this. So at the very beginning you can see we are using TypeScript. You can see it on the TSX file, and we're using Apollo client. Apollo client is from Apollo, of course, and it's going to help you set up GraphQL on the client side very easily. So what we've done being here, we've created our Apollo client based on this server. And this server is actually something that I put in Code Sandbox, and it's running in the background. GraphQL server. Start it up. That's something we should do before trying on, because otherwise we would query a server that wouldn't be there. Actually initializing the server now. Yeah. So this is the GraphQL playground, and this is a mutation we saw before. And this is basically my GraphQL server. So let's zoom in a bit more. And what I've did on my client-side application is I'm going to retrieve information from this GraphQL server, and I'm going to use GraphQL code generator to create types based on my schema. And the schema is what you see right here. So this is actually the explorer for the schema. We can see we have queries and mutations, and something we can do is retrieving products using a query, and it will return something of the type product in array form. So we can see if ID, title, string, thumbnail. And looking at the slides we just saw, you can already assume what those types will be in TypeScript, right? But you probably don't want to rewrite those types every time you change something to the application. So let me go here and just run this application. Time to set up. It starts my developer server. And you can actually see this really nice application, right? So basically what I'm doing here, I'm going over some information and just displaying it here. Something that I did client side is this. So I've created a component to get this product information, and now I have all my interfaces or types defined right here. So basically, every time I change something in my schema, I have to redefine those interfaces or those types in my product, in my front-end code. And you can see I've got my query defined here. So when I use Apollo in this way, I need to add my typings everywhere. You can see some generics being added, and you can see the query that I'm requesting. And also, whenever I'm going to find a relationship, so our GraphQL query, you can actually try this GraphQL. So let's going to see what my data will look like that's being returned. So this is what my data would look like in the application. But actually, if we ask a server what this would look like, it's going to return this, right? So as you can see, it returns data, products, and then it's an array. So in our code, actually, we need to go over the data, the products, and then we have to map the array. But then we need to define those typings everywhere, right? Because otherwise, we wouldn't know what this is. So we probably wouldn't know what would be the field of title. So every time I change something in my client-side application, I need to update those types. So that's something, if you can probably understand, this is something you want. So that's why we use GraphQL Code Generator with these settings right here. So let's first just try to create some TypeScript types from it. So this is my GraphQL server that's running on Code Sandbox, and it's going to return my typings in the file that I asked for. So I'm asking for generated GraphQL TSX. So like what I just created here, I'm going to use it to create direct Apollo components later on. So that's why I call it TSX file. And it's going to return this data right here. So delete this one for now. And in my package.json, I already inserted all the code to run the generator. Basically, it's this GraphQL codegen config codegen YAML, and we're going to execute this file. Run this one, rpm generate. Now the CLI is actually working. It's parsing my configuration and it's generated the output. So it just generated this file existing of my TypeScript types based on my server. So in here we can see we have product. Well, product consists of ID, title, thumbnail, and it's a string. It's an integer. This is also a string. And as you can see, it generated those types automatically. So in my products file, I can probably get rid of this one because I'm not using it, right? It's being generated for me. Plain. Let's see if VS Code can help me doing it. Yes, VS Code can. So now I actually already created this product for me. So it already saved me some time. And apparently it doesn't know it also has offer, so offer as well. Automatically. Yes, so here's the offer type. So using just GraphQL Code Generator, I can already get rid of all the boilerplate I have right here. So maybe I can find this one. Well, this is actually a specific typing I made for Apollo. So we probably still need to have that one in. But those typings, we already saved some time by it. But the real magic is patience, probably still working. Not running anymore. If it still works. Yeah, you can see everything is still here. So no runtime errors, so that's good. And we already deleted all those boilerplate. Right here. So this is code we already could delete from our application. Just by running GraphQL Code Generator and having a lot of optimizations because we just don't have to create those types again. And something I already briefly deleted from here is you can do way more with GraphQL Code Generator. You can also create operations and we can create React Apollo components. So this is actually what makes it real interesting. Right, and run the generator again. So generate the component for us. It did. Application. So now it does some more for us as well. So next to just creating TypeScript types, it also created a component for us. Where did I put the component? We forgot to save the file. Makes sense. Again. Now it should be here. Created all sort of stuff for us. It also imported Apollo inside this file where it generated the component. And in here you can see it created the component, so get products component. So that actually looks way better, right? Because now we can probably get rid of this query because we also have the get products component. Let's try and see if that works. Get rid of all the query boilerplate. This one here. Okay, let's see what's happening over here. It doesn't need those typings anymore, so let's get rid of those. So now we have just one component. It's basically doing the same thing as what we did before. So rid of. Well, now we're using a query component from Apollo created by GraphQL code generator. And if we look at our front-end code, it's still running. So we're actually able to reduce all the types from this file. So there are no type definitions anymore. And it looks really clean, right? Because this component is already strongly typed. So it will know the field, the format of data, the products in there. It will know all the fields inside a product object. So basically all the type definitions that we put in here, those are deleted now. This file, you can see we've already deleted like 20 files from the top. And then also some files in here. So basically we went from 61 to just 43. That saved us a lot of time already by using this. And if you can imagine, if you have a lot of components in your file, you don't want to have those generics for get products in over there, define your query, if you can also automatically create one with the GraphQL code generator. And this also works for hooks. So if you would be working with Apollo hooks, then you would want to do this as well, right? Let's see if we can make a hook file out of it. Let's grab this one. Probably if you're not familiar with React, it doesn't really make sense what I'm going to do, so sorry for that. See those things. Component can be well. So basically we can get rid of even more code in here. This one is, we don't do that anymore. And then we're going to use a component called useQuery. So it will look like this. We're going to return data. Loading is use query. Note this one. And then in this query, we need to define our actual query. And the strong typed query is something that should also be created somewhere in this file. So probably it looks like it's called get products query. It's called get products document. See? Let's see how we're going to return this one. You know, I already created one here, so let's use this one. Apparently, we need to write it a little bit different. This. And now we actually can't really use the strong coded because probably we need to define. Yeah. So if we're going to use hooks, then we can't really use the strong typed component. So then we would still need to import like the product type right here. And then the offer type right there. Import it as well. It's not as fast. And now probably it will still work. So we can again get rid of the query, not using the component. This one. And if we look at the application, loading. Just get this one in here. Yeah, if you look at the application, I'm going to look what I did wrong later on. So this is actually the same example, but just using React Apollo query components. And we're still strongly typed. The only downside is that you need to define the relational fields right here, like one by one. But again, if you don't have to create your types and you can just import them from the generated files, then it will save you a lot of time, because all those things are actually what will break your application. And just suppose that reseller, it's saying over here, suppose it's being renamed to like reseller name, and you would have to update all those typings, and it's going to cost you a lot of time doing so. And like I told you, you can also use GraphQL code generator on the server side. So using just the schema that you have on your server, you can actually create the typings for it. And if you're creating resolvers, then you don't have to create the types for every resolver. And as your resolvers are tied to schemas in GraphQL, that's something you don't want to do over and over again. So that's basically how you can work with GraphQL code generator. If you want to know more about this, just go to the website of GraphQL code generator. Or if you want to know more about type GraphQL and how to create GraphQL servers from TypeScript types, then type GraphQL is the way to go. I'm actually working on a new GraphQL book, and I will be using type GraphQL in there as well. So if you just follow me on Twitter, you can learn more about it later on. Or we probably still have some time to ask me some questions if you have any. Thank you.
Thank you, Roy. We're gonna wait for a question. So, okay, first question. So, what do you think of custom GraphQL scalar to create opaque types on the TypeScript side? Would you recommend it using a unique symbol?
Oh, that's an interesting one. I don't know. I'm not really a fan of going against specification. So GraphQL is a specification which is quite new, and there are just some basic scalar types in there. And if you're going to create more types on it, I'm not sure if it's something I would do. I'd rather go for relationships and try to keep it more simple. But I don't know. I haven't actually explored it this way, because for now, I believe it's still specification is still going on. It should be interesting to stay as close to that as well.
Okay, thanks, Roy. Another question. So, type GraphQL is amazing, but what's your opinion of GraphQL Nexus schema?
Yeah, it can work for. I haven't actually used it myself, but it can work as well. So there are different ways to actually handle GraphQL schemas and GraphQL server creations, and how to reuse types. I see someone asking a question about Prisma as well. So there are multiple ways to use an existing data source or use types to create a GraphQL server, and I think you should actually use them. So especially if you're migrating from something that already exists, so maybe you already have a database that you want to hook onto, then something like Prisma can really help you. And if you're building something from scratch, then type GraphQL can be real interesting. So if you already have a data source, you should definitely try and find a way to use the schema from that data source to create your GraphQL schema, because GraphQL schema should just be a thin layer on top of your already existing logic, and you don't want to redefine everything every time you're changing something in your data source. So if you're currently working with an existing data source, just try to find something that can hook up onto it.
Great. So next question is GraphQL types from TypeScript or TypeScript types from GraphQL? I'm aware that Nest.js, for example, can do both. Any preference between the two?
Oh, I guess I would say it would be best to create. It depends. If you've got a new project, then probably you're going to want to create your schema from your TypeScript types, because it will give you more freedom. But if you already defined the TypeScript schema, a GraphQL schema somewhere, and you want to use TypeScript, then probably do the other way around. So I think it really depends on where your existing code base is right now.
Okay, thank you, Roy. The next question will be difficult. So why didn't you use the Apollo hooks that still strongly types? For example, the next line, const. Yeah, you have to see that in the.
Yeah, that's a really good question. I think that's someone that already knows GraphQL code generator because I could have used the strongly typed hooked. Yes, smart question. So basically, what the code generator does, it creates strong typed components, but it can also create strong typed hooks, like someone's suggesting. So that would be a real good one to use.
Okay, thanks. And which GraphQL implementation would you prefer between Apollo and Relay?
Oh, that's also a difficult one, and I think it's kind of opinionated as well. So it also really depends on what you're used to. So if you really want to get really deep into the specifications of GraphQL, then Relay is interesting because it's going to give you more customizations. And if you want to get started with GraphQL real quick, then Apollo is probably what feels the most familiar to you. So I believe the new Facebook is being rebuilt using Relay. And if you're looking into React and concurrent mode, then Relay is going to offer you um, a lot of ways to use GraphQL concurrent mode in the future. And I think with Apollo, it's a bit tougher. But Apollo is more beginner friendly. So again, this is also something that really depends on where you're coming from.
Yeah, thank you, Rose. Yeah, so much too. Okay. We get another question. No, I don't know. Yeah, I think that's all. No. Okay, so again, opinion. So any opinion on GraphQL clients other than Apollo, such as Urql or GraphQL request?
Yeah, so I've been using Aircall or Urquell. I'm still not sure how to pronounce it, but I've been using that one most of the time because it's a bit more lightweight than Apollo. So Apollo comes with a lot of things to optimize your code, like caching. Um, but if you're not looking for things like caching that are already in there, then Urquell can really help you to get started real quick and also real lightweight. So it really depends on your application as well. And also Aircall is real good documented. So for now, I think I have a preference for Aircall.
Okay, thank you, Roy. And that's all. We don't have another question. So thank you very much for your talk.
Yeah, no problem. And I'll enjoy your night.
Yeah, thanks. Okay, so now. Okay, that's all. No other questions. So thank you everyone to follow this this live event. Thank you, Roy and Andrey. And thank you, Paridino, to help us to set up this event, like I said at the beginning. And we will do another meetup online in the next month. So don't miss news and follow the Paris TypeScript Twitter account. And that's all. Thank you all. Bye.